students, welcome to the cbse chemistry lecture series. So in the last video we discussed about the electronic effects. Among the four electronic effects we discussed inductive effect and electromeric effect. Now in this video we are going to discuss about resonance or mesomerism. What is a resonance effect? Suppose it is not possible to assign a single electronic structure to a molecule which can satisfactorily explain all its properties. In such a case, it has been found that the molecule can be represented by two or more electronic structures, each one of them which can explain most of the properties, but none of them can explain all the properties of the molecule. The real structure of the molecule lies in the molecule in between all these electronic structures, however, cannot be represented on such a paper. For example, you can take a benzene. So this is a benzene structure. This single electronic structure alone is not sufficient to explain all its properties. It has more similar structures. See here, you just change the bonds. This is a similar structure of benzene. These two structures proposed by the scientist Kekulé. Similarly, the other structures of benzene also there. So these three structures proposed by the scientist Dewar. So these are all called, we can call as resonance structures or canonical structures. Canonical structures. The various Lewis structures are called canonical structures or resonance structures. The actual structure of the molecule is not represented by any of the resonance structures, but it is a resonance hybrid of all these Lewis structures. The various resonance structures are separated by a double-headed arrow mark that indicates these two are called resonance structures. Similarly, instead of putting the similar structures, you can put a double-headed arrow. For this case also, these are all called canonical structures or resonance structures. Similarly, carbon dioxide molecules, we can write like this: C double bond O double bond O. If you write a canonical structures for these compounds, you write the electron dot formula or Lewis dot structures. So in this case, this will be what? To minus charge, minus, or you can shift it to this one. This lone pair of electron will be shifted to this side. So you got write what? Double bond minus single bond carbon triple bond O positive charge. This is another similar structure of carbon dioxides. We can also write one more structures like O plus triple bond here CO minus. These are all resonance structures of carbon dioxides. So what is the conditions for resonance? Conditions for resonance. Number one, the various resonance structures should differ only in the position of electrons and not in the position of atoms or nuclei. Various resonance structures should differ only in the position of electrons and not in the position of atoms. That's the first conditions. Second conditions, all the resonance structures should have the same number of unpaired electrons. All the resonance structures should have same number of unpaired electrons. And the third condition, in case of atoms of the second period in the periodic table, in case of atoms of the second period in the periodic table, such resonance structures which violate octet rule should not be considered. I will give an example for this case. You can take an example of CH2 double bond CH NH3 plus. You just shifting this electron to this one. So CH2 plus single bond CH double bond NH3. Is it possible? Means it is not possible. This is only for because the nitrogen atom is present in the second period in the periodic table. That is why these two are not resonance structures. These 1 and 2 structures are not resonance structures. Now we will explain resonance effect. You can say R effect or mesomeric effect. M effect. Okay, so this is we can take an example of conjugated systems have alternate sigma and pi bonds. Conjugated systems like having alternate sigma and pi bonds. Say for example, you can take an example like this: CH2 double bond CH Cl. You want to fill up the valence electron of this chlorine. Yes. And you want to write the similar structure of the structures. This you have to shift these electrons to here and here. What will happen? It will become a CH2 minus CH double bond Cl plus charge. Okay. Here groups which donate electrons. There are two cases. One is groups which donate electrons to the double bond. Or to a conjugated system, are said to be plus R effect. Suppose if groups which withdraw electrons from the double bond, or conjugated system, that is should be said to be minus R effect, or otherwise known as Mesomeric effect. Which are all the minus or effect and plus or effect? I'll explain to you. The minus or effect, the groups which are C double bond O, CHO, COOR, CN, NO2, etc. If it is a plus or effect, OH, X, OR, etc. So this is a resonance effect, or I can say mesomeric effect. So thank you students. If you have any doubt, please mention the comment box. Thank you students.